Hello there, Mr. Sutton here with the AB Calculus 3-6 Classwork Extra Practice Solutions on derivatives of trigonometric functions. To find the derivative on this one, we're going to need to use the product rule. I guess you could move this x downstairs and make it a quotient rule, but, why bother? So we've got u prime v plus uv prime. Setting up my box and ribbon, I've got 6x to the negative 2 and sine of x. The derivatives on these, we've got, let's see, this will be negative 12x to the negative 3. Derivative of sine is cosine. Using my ribbon to put it all together, I've got negative 12x to the negative third times sine of x, plus 6x to the negative 2 times cosine of x. And they said don't simplify, so we'll leave it like this. To take the derivative of this function, we're just going to go from left to right, term by term. So derivative of x cubed is going to be 3x squared. For this next one, derivative of cotan by itself would be negative cosecant squared. With a negative 3 out in front, this becomes plus 3 cosecant squared of x. And derivative of 2 is just 0, so we're not going to write it. To find the derivative of this function, I'm going to need to use the quotient rule. So that's u prime v minus uv prime all over v squared. Using my box and ribbon now to organize all of this, I've got my numerator, cosine of x. Denominator was x. And then their derivatives, we're going to have negative sine of x, and this will just be 1. Coming back here now with my ribbon to put it all inside, we've got negative sine of x times x, that would be the u prime v part of this, minus uv prime, so that's minus cosine of x times 1, which is just cosine of x, all over v squared, so that's going to be the x squared in this case. We don't have to simplify, so we're not going to. We're just calling this done. For this problem, they wanted us to figure out the derivative of this function and simplify. Of course, they never said when we had to simplify. This one's actually a lot easier if you simplify right away. Cosecant, for example, we know that's really 1 over sine of x. 1 over sine of x times sine of x is just 1, because those cancel. Now be careful, you haven't actually taken a derivative yet. The derivative of 1 is just 0, and we are done. For this problem, we need to take the derivative and simplify this thing. So we're going to start off with the quotient rule, u prime v minus uv prime over v squared. Let's set up a box and ribbon to organize that. So for my numerator, I've got 1 minus secant of x. Denominator over here is going to be cosine. And derivatives of these, this becomes 1 minus secant of x is going to become negative secant of x tan of x. The 1 just goes away there. It's a 0 if you take a derivative of a 1. And derivative of cosine, that's going to be negative sine of x. Let me use my ribbon to put it all back together. So we've got negative secant of x, tan of x, cosine of x, minus 1 minus secant of x in a parentheses, and we have a negative sine of x going along with that as well. Oh, there we go. And now we need v squared. That's going to be cosine squared of x downstairs. Now it's time to simplify this stuff. So one thing I can do to start simplifying, all this stuff we can get rid of the parentheses. And this stuff over here on the right side, we can distribute this negative sine of x. Now this negative and this negative kind of cancel, so you're really just distributing sine of x to 1 and negative secant of x. So that's going to be sine of x minus sine of x secant of x, or secant of x sine of x, either way. Now we have to keep going if we can. Now there's a whole bunch of different trig functions here. I bet if I turn a few of these into sine and cosine, I can get a couple things to cancel out, or at least simplify a bit. So for example, secant is really 1 over cosine. That's going to cancel nicely with this cosine. This secant is also 1 over cosine. Sine over cosine would give me tan. So initially I turned those secants into 1 over cosines. And yes, I could do the same kind of deal with tangent, but I just chose not to. So here on the left side now, these cosines cancel. We just have negative tan of x over there. We've got a sine of x, and this is going to be negative tan of x over on the far right side if we simplify that. So we have negative 2 tan of x plus sine of x. And that's about as good as this thing is going to get. So we're going to call this done. On this problem, we're trying to take the derivative of x plus sine of x. This is pretty straightforward, left to right kind of deal. Derivative of x is 1. Derivative of sine of x is cosine of x. Put them together, and you've got answer choice A. On this problem, we're trying to take the derivative of tan of x minus cotan of x. Going left to right, we're just doing these one at a time. Derivative of tan of x is secant squared of x. Derivative of cotan by itself is negative cosecant squared, but we already have a negative there, so that's actually going to be plus cosecant squared. And we don't even need to simplify this in any way. This is just going to be answer choice E. For this problem, we're trying to take the derivative of x sine of x. For this, we will use the product rule, u prime v plus uv prime. Let me set up a box and ribbon to organize things. So we have the factors x and sine of x, and the derivatives of those, which are 1 and cosine of x. Using the ribbon to put it together, we've got 1 times sine of x plus x cosine of x, and that appears to be answer choice B. On this problem, they want the limit as h approaches 0 of this stuff here. This is really just the limit form of a derivative. The original function appears to be whatever's plugged, this x plus h is plugged into, so sine of x is the original function. And they just want the derivative of that, which is cosine of x. So that's going to be answer choice D. On this problem, we have this line L that's tangent to the graph of y equals cosine of x at the point k comma cosine of k. And we know that k is between 0 and pi. That's going to be helpful when we have to graph stuff out. We want to know at what k value does our line pass through the origin. Well, let's start by writing the equation of the tangent line. So in order to do that, we need a x value, a y value, which they kind of gave us, k and cosine of k. K is a constant. We also need the derivative, the slope of the function at x equals k. So first we take the derivative of the general function here. Derivative of cosine we know is negative sine of x. And that means that y prime of k is going to be negative sine of k. That's going to be our slope. So y minus k, cosine of k, that's going to be the y minus y1 when we write out our tangent line. We've got negative sine of k that this equals for the slope, and then we'll have this times x minus the x value k. So this is just point slope form here. Next, if we're going through the origin, that means we're at the point 0, 0, so we can rewrite this as 0 minus cosine of k equals negative sine of k times 0 minus k. And we can clean this up a little bit and just write negative cosine of k equals negative k sine of k. Actually, positive k sine of k. If I distribute, I get a negative times a negative. So negative cosine of k equals k sine of k. We're going to go ahead now and graph this and solve it on the calculator. So here we go. I've entered the left side of my equation in y1, the right side in y2, and you notice I'm using x instead of k because that's how my calculator graphs things. But when I solve for x on the calculator, we understand that I'm really solving for this k value here. Now for the window, they said k is between 0 and pi. So let me go to window and put in 0 for my lower bound, and I'll use pi for the upper bound. And then let me do zoom 0, zoom fit. And let me see if I can see those two curves intersecting each other anywhere here. So there was negative cosine of k, here's k sine of k, and they do cross somewhere on this interval. So let me do second trace, option 5 for intersect, and then let me just arrow over here a little bit, just to be on the safe side. So enter once, enter twice, enter a third time, and we have the value 2.798 for k. And that's going to be answer choice D.